Hello friends, my name is Harshit Kedia and I am a data science and generative AI student. And in this video, I will be sharing with you a project which I have practiced, which is about fine tuning a hugging face model with custom dataset for text summarization task. So let me start the project how I have created the IPYNB notebook. So first we will be checking the device. First we'll actually connect with the um, GPU on the after selecting the change runtime. Here we can select the GPU and save, and then we have to connect it. We don't have to perform it with CPU, we have to perform it with GPU, otherwise it will take a lot of time. And if you have a free Google Colab subscription, you can take a T4 GPU connection. So we will be, after connecting from T4 GPU, we will be checking the NVIDIA configuration with this, and it will show us that it will be having a GPU right now running. And then we will be installing the required libraries. I will keep this notebook link in the description, so from there you can download it and practice and check if you require any libraries or some code from here. Actually, while we will be downloading this and installing these libraries, sometimes give error because they will be running on the old version on Google Colab, which will have some compatibility issues. So first you have to upgrade it and then uninstall these libraries and then reinstall it so that it downloads and installs the new version. Then we will be importing these packages and libraries. I will be sharing with you while working on the code below, then what the libraries which we have imported, what are the use of those. So over here we will be seeing if GPU is available. We will be using CUDA, which is a GPU related, otherwise it will be using a CPU. So this, if GPU is available, it will automatically select GPU, otherwise it will select the CPU device. So this is there. Then we will be downloading the model tokenizer and hugging data set from the hugging face. The model name Google Pegasus. This model is there, which you can see on Google. If you search it, you will get the link for hugging face related to that. So you can see it from here. Over this, they have given the details about the model as well as the code related to it. So the model name we have selected in this variable and then taken the tokenizer. So we will be downloading the same tokenizer related to the model name. So we will be downloading the tokenizer using from pre-trained function in auto tokenizer library, which we downloaded earlier, and we have kept the variable name which contains the model name. Then we will also be downloading the model actually from using this library auto model for sec to sec lm. It has a function from pre-trained. We kept the model ckpt variable which contains the model name actually, and then it will store that model to our device. We will also be loading the dataset using load dataset library, and the dataset will be Samsung dataset. It is available on Hugging Face. In fact, let me show you the dataset on Hugging Face. Yeah, so this dataset we will be using. Related information about the dataset you can find on the website link itself. So while we will be checking the details about the dataset, if you type the dataset, we have saved it in this dataset Samsung variable name. If you type this variable name, it will give the information about it. We have a train, test and validation, three subsets are there. And if we want to check what's the content inside it, you can see the features are there: id, dialogue and summary. So actually a task is to summarize the dialogue into a summary, and for that we need the um, previous data, means the data on which we need to train. So if you see the data set, we see the train subset. In that we will be seeing the first, in fact it will be the second record in that subset, because records in a data set will start from 0, so 0th and then first will be actually the second record of that data set. So this record, and then in that we will be selecting the dialog feature. So these are the dialogues in the data set. Then the from this we can, if we want to see the summary, in place of dialog we just have to give this summary over here. So this is the summary of the data set. Now we want to see the respective lengths of the different subsets. Like over here we saw that there is a train subset, test subset and validation subset. We want to ensure that we how much is the length of the respective subsets. So for that we will be using the split length function, and then the split lengths will be printed. Then if we want to see the feature names inside the subsets, for example in the train we want to see the feature names, we will write the dot columns names. It will give the feature names in that ways. And then if we want to give a blank line, as you can see over here the blank line is there between these two, we will be putting /n and then whatever we want to print. So for example dialog is written over here, so we will write dialog. Then if we want to see the dialog, actually what's the data inside the dialog, if we want to printed, that it's the related code. Actually in the dataset, Samsung dataset variable which is there, we see the test subset. Inside that this record number we are mentioning, and in that the feature name dialog we want to see. Okay, so over here we will see we will print this. So what things we printed the split lens. You can see the split lens is there, features are there, 3 features which are getting printed, and then the dialog is getting printed. And then also we have a blank line over here, and then a summary. For the summary we are seeing the corresponding summary of the same record. As you can see tests in the test subset, the same record number, and then we are seeing the summary feature. So for this dialog itself, this is the dialog you can read, and this is the corresponding summary over here. So in this way there will be many such records on which our model will be actually trained. One more thing, when we want to train the model, the ML algorithm cannot understand the English letters or words, so we need to convert these dialogues and our text into a machine readable code, for which we need to encode the text actually. So the tokenizer actually encodes the text and uses some actually, since we are using the tokenizer from the Hugging Face itself, as we have mentioned earlier over here, let me show. We are using the tokenizer from the Hugging Face based on this model actually, and these are transformer based models, so the tokenizer is also a transformer based tokenizer. So because of that it will be better than the conventional tokenizers, like we are having bag of words, TF IDF, and word2vec, etc. But this will be better than those ones because it's based on transformer architecture and is also very well pre-trained by the model provider itself. That's why we will be using this one. So this is a function we are passing an example over there inside this example batch. Actually we will pass an example of batch. First we will be actually dividing the dataset into batches and then pass the individual batches inside the function for encoding. So input encodings will be converted for the example batch, and this one will be for the dialog feature. So dialog feature will be converted into an encoding, and then with we will be also encoding the summary feature, so that it will be helping us in the model training actually. So in this case we will be putting this tokenizer dot as target tokenizer, so that it knows that it's the target variable actually. Otherwise, it by default it will be taking it as the original variable, like the dialog will be the basis for which it's the input from the user, and this is actually the output for which the model is providing summary. But that thing we need to tell to the tokenizer that this is the output target thing and this is the input one. So for that we need to put this as a target tokenizer over here. After converting, it will be returning three things: input IDs, which is the actually encoded encoding, which over here you can see input encodings. In input encodings, there will be a thing called input IDs, which will be containing the um, tokenized tokenized input from the this dialog. And attention mask will be the same thing from the input encoding, but it will be containing the attention masks for the corresponding dialogues. Like the actually in attention mask, what happens, let me show you with an example. Over here we are having an attention mask over here, suppose. So what's the thing is that we will be having, since we will be converting the complete sentence or complete text into tokens, the model will need to evaluate where it needs to put special more attention, and on which words or which tokens it needs to not put the attention, or it needs to give more attention to some words other than the others. So for the words which it will be giving attention to, it will be marking it as 1, and those which it will not be giving attention, it will be putting as 0. So in this example we can see that for the attention mask, it has put all the words as 1, which means it is giving attention to all the words. Actually, when we will be having the sentences, suppose that 10 words are there in that. So it will start from it will be containing 10 words in the input IDs, means corresponding 10 words will be converted into input IDs. Or it's not even necessary that it will be converting word by word, it may split it into sub words or something like that. But in general I am saying, if we consider one word as a token, so corresponding number of 10 words will be converted into corresponding number of input IDs. So and input IDs will be like this: 151, 2632, these kind of things. So for the input dialog, we will be having input IDs, which will be the corresponding tokens of the corresponding words or words in the dialog. It will be the corresponding encodings of that, and then attention mask will be there of that same tokens or encodings, which and it will be in the corresponding way that which token it needs to give attention to, and which it does not need to give attention to. These all things will be based on the machine learning tokenizer which we have downloaded. It will judge that based on its algorithm. So attention mask will be there in that case. It will be having 1, 0, 1, these kind of values. And then labels will be the encodings of the summary, corresponding summary words or tokens which will be encoded. So this will be containing the as labels. So for each record it will be returning the input ID, attention mask and label. Input ID and attention mask will be related to the dialog, and labels will be related to the summary. Okay, so now when we over here you can see dataset sum pt. Actually this is a new variable which we actually map the dataset samsum. The dataset samsum actually has a build. This is actually a object of the dataset class. So the dataset class has a map of map function built in it, which helps us to apply the this function which we have defined, actually in the map function we can keep a custom function which we have written, and it will be applying that function to the corresponding records in that data set class. So since this is the data set classes object, so we have applied the map function, and in the map function we have kept the custom function which we have defined. So it will be applying the function to all the records correspondingly in the R object, and the result we have assigned to a dataset Samsung PT. This is a new variable or object which will be getting the values which will be returned by this function, and corresponding to the records means all the records which have applied on that this function will be there, and that will be stored in this variable dataset Samsung PT. And batched will be there, which means the function will be applied in batches, means it can take 100 records at a time, apply that, and then again 100 records in that ways. If batched is not there, then it will apply on each record one by one, which will be a slow process. That's why we are applying batched equal to true. Okay, so now this new object is there. If you want to see the train subset, since our original dataset was also having three subsets, so after applying the map function also we'll getting three subsets in this. So if you want to see the train subset, what features it is having, over here you can see we were having ID, dialogue and summary originally. Now input IDs, attention mask and label, as I told earlier that these three functions, three features will be added, so these three are added in this. Now if you want to check what's the content inside the input IDs, as I told earlier, input IDs will be having the corresponding tokens encoded from the original text into some encoding. So these are the encodings for the corresponding first record actually. Now since this is the record number in that, and this is the feature, and this is the train feature inside the this object in this dataset class or object. Now if you want to see the 0th record, this was for the first record, or in fact the actually if you count the starting from 1, then this is the second record in our dataset, but it is labeled as 1 because the counting starts from 0. So this is the 0th or the first record, we can say. For that correspondingly we are having these IDs, and you can see the attention mask for the this number record in the same train in the this dataset object. Now we have got our input IDs and attention mask, and the one these labels related to the input and output, means dialogue is also converted into encoding, and the summary is also converted into an encoding, so we can perform our machine learning algorithm in that. So let's start our training process. For that we'll import the data collator sec2sec library. It helps in batch processing inside the ML algorithm training. So this library helps us to process the data in batches inside our while our training in the ML algorithm. So there we have created the object out of it. We have to pass the tokenizer and model in this. So over here we have the training arguments and trainer, these two classes we have imported, and in the trainer arguments we have to training arguments class we have to pass some arguments. Most of these are like default only two are important over here. The output directory, where we have to specify our model, we have to specify a directory actually where the model will be saved in the why if we want to save the model. And then the number of epochs, actually because it was taking too much time for training, so because this is a practice, for practice purpose I have kept the number of epochs as 1. But when we want to train the model for actually commercial purpose or for our real prediction purpose. For a good training we need to keep a good number of epochs, but this is a practice project, so I've kept it one only, and the rest of the parameters are can be kept as default. So this is a training arguments. These training arguments are specified, and the trainer is there now. So in the trainer class we have to specify the model equal to model because arguments we have given from the trainer arguments variable, which was used for specifying the training arguments, trainer args. Tokenizer we have specified. Data collator, I told earlier there was a data collator object we created before earlier. We have specified this. Train dataset equal to dataset sum. This was the, you know, the object we created with the encodings labeled in, like we had tokenized, and we had tokenized the text into encodings, and we can use it for the training purpose. So this will be the training dataset, this will be the evaluation dataset. What we are feeding in the train dataset is a technical thing over here. What I did is as a hack was that since there were so many records in the training dataset, it was actually 10,000 plus records, and so training would have taken a lot of time. And since this is a practice project, for the practice project purpose I just kept it as test, because test was having only 800 or 900 some records, so the training process would have been faster, and validation was also having some 800 or 900 records, so for evaluation also we could do it in a fast way. So just for the practice purpose I have kept this as test, otherwise it should have been train, and this one should have been the test one or evaluation. So but in the commercial, in the industry practice, we our criteria should be that we should have more and more number of records for the training, because the more number of data and good data will be there, the better the model can be trained. So but this is the for the practice, so I have just kept it as small numbers for small number of data only. Now we can put the trainer.train and the training will start. One thing I want to tell is that when we will be starting the training, it will ask WANDB API over here, for which you have to create an account over WANDB.ai, and then if you click on this link, it will generate an API key for you, which you can feed it while it will be asking an API key over here. So the what's the use of it, I will be sharing before it to you right now. For if you put the API key and then the training will be happening, then it will create some good number of charts for you, like what's the training, what was the graph about the different parameters about training. So this kind of graphs it created for me when I entered the API key with the same project I was working right now. So this is the benefit if you want to keep it. If you don't want to see this graph, and you don't want to give an API key over here, then you can set the report to equal to none in the training arguments. So in this training arguments you can add a parameter like report to equal to none, so then it will not ask you an API key, because it will not be requiring to create a graph anywhere in that case, because you instructed that you don't need that actually. So when this will be there, then your training will be happening, and you can see the epoch and the total loss, training loss, these kind of things will be there. And then when the training will be completed, then we can start the evaluation process. For evaluating the summary based um, summary based models, we can use the rogue matrix, Roge matrix, whatever we can pronounce. So for this, first we have to do the thing that we have to generate batch sized chunks for putting it into the, actually for putting the data set into this function, we first need to divide it into chunks. So this is the for that we have written this function. It will keep on giving you the list of elements from I to I plus batch size from your data set. So over here you can see we have used this generator batch size function, size chunks over here. So we have used a yield function instead of return, so that it will become a generator function, and then when we will be using a list, so what it will be yielding, the it will be generated in a form of list. So let me show what will happen when we use this function. So we will be giving these arguments: dataset, metric, model, tokenizer, batch size, device, column text, column text. Actually, column text is the um, column text is the text which we want to get summarized, and column summary is the summary which has come out as an output. So um, so what we are doing over here, article batches, we are getting the uh, uh, over here you can see this article is there. So actually this column text will be having the text of the things which you want to give to summarize. So actually it will be dialog. We will be, when we will be using the function later, we will be putting it as dialog. Or for the default value it has kept it as articles and highlights, otherwise it will be dialog and summary. So using this line of code, article batches equal to list this thing, it will be generating the dialogues as a list of and each of the element in the list will be the size of the batch size which you want to give. If you want to give the batch size of 16 suppose, then there will be 16 dialogues combined as a list which will be serving as the article size. Similar for target batches, target is actually the summary. So if you want to keep this it as 16, as each of the element of the list will be having 16 summaries inside it. Or what we can say that each of the this target batches list will be having 16 elements, which each of the element will be a summary in that. Similarly for article batches, each will be a summary, each will be a dialogue, each element of the 16 elements will be a dialogue conversation taken from the data set. So these will be corresponding only for the corresponding article batch. We will be getting a corresponding target batch. So for that we will be zipping both the article batch and target batch into a tuple, and then inputs